So today we want to talk about binary covalence and specifically binary acids nomenclature. So two different naming rules today, but they're both fairly straightforward. So our EQ for today, please write this down. How do I write names and formulas for binary covalent compounds and binary acids? Okay, so up until this point we've talked about ionic nomenclature, and I want you to take everything we did with ionic nomenclature and I want you to set it over there. Because here's the deal. This is totally different. Totally different. Okay? 100% different. So let's refresh our memory. With a covalent compound, this means that we have a nonmetal and a nonmetal. Remember that the word binary means made of two. And today we're going to actually define what an acid is. This is a word that you've heard before, but scientifically speaking, what makes something an acid? An acid is going to be anything, any substance that supplies H plus ions. So we're going to get more in depth. We have a whole unit on acids and bases. So we're going to get more in depth about what acids are and why they function the way they function in that unit. For the purposes of naming acids, I need you to be able to recognize naming acids. So the key with acids is that they always start with hydrogen. Every time. Acids are always going to start with hydrogen. So when we're doing binary covalent nomenclature, if it starts with hydrogen, we're going to use acid rules to name it. We're not going to use the binary covalent rules for it. So we're going to keep those two things separate. So let's start with binary covalent because I think you'll like it. It's pretty easy. All right, so binary covalent. Let's start with to write the name. Okay, to write the name, you are going to look at the subscripts. Those are the little numbers at the bottom for both elements. Then you're going to match it to a prefix. Now, the prefixes are on your pink chart. Okay? All of the prefixes are on your pink chart, okay? And I'm going to go over them in just a second, okay? But let's put down step 2. You're going to write the prefix for the first element plus the name of the element. The only exception here is if it's a 1. If it's a 1, you don't write a prefix on the first element. Okay? And then after that, you're going to write the prefix for the second element plus the name of the second element, and you're going to change the end to IDE. And here, even if it's 1, you use the prefix. So what are you talking about, Miss Crane? What prefixes? Okay, so we have 10 prefixes we use. There's more than that, actually, but we aren't ever going to go beyond 10. Okay? 1 is mono. 2 is di. 3 is tri. 4 is tetra. 5 is penta. 6 is hexa. 7 is hepta. 8 is octa. 9 is nona. 10 is deca. Okay? All these prefixes are on your pink chart. So you don't have to memorize them. You do have them. Okay? But that's how this works. Okay, so let's do an example. Let's say I have B207. Okay? So the first thing I'm going to do is I'm going to look up my prefixes for 2 and 7. 2 is di, 7 is hepta. So I'm going to write the prefix for the first element, which is di, because there's 2. And then the name of the element, B, is boron. Then I'm going to write the prefix for the second element, 7 is hepta. Now, here's a little trick. The element here is oxygen. And we don't love double vowels. We usually will drop the A on the prefix vowel. We'll drop that A if it's hitting like an oxygen or something like that. So instead of saying heptaoxide, this would be just heptoxide. And remember, we want to change the ending of oxygen to IDE. So this would be diboron heptaoxide. Okay? Let's do another one. Let's do, a very common element, CO2. Okay, so first we need to look up the prefixes. Now, carbon doesn't have a number, so we of course assume that it's a 1. But remember, on the first element, we don't use a prefix if it's a 1. So we're just going to write carbon. And then we have a 2 on the oxygen. The prefix for 2 is di, so we're going to put di. Oxygen becomes oxide. So this is carbon dioxide. Very straightforward. Okay? Going back the other direction, super easy as well. If I have, for example, triphosphorus, pentasulfide, okay, I find that means 3, so I have 3 phosphorus, and that means 5, and I have 5 sulfur. So I have P3S5. Super easy. Names and formulas. Done. That's it. Okay? So now let's talk about what if it starts with hydrogen. So this is binary acid nomenclature. Now we're going to talk about a different kind of acid tomorrow, which is oxyacids. Those are different. Okay? For binary acids, to write the name, you're going to write hydro, and then the root of the nonmetal, and then ic acid. That's it. So HCl would be hydrochloric acid. H3P, hydrophosphoric acid. That's it. Okay, to write the formula, it's a little trickier, but it's cake compared to what we've been doing with ionics before the break. So to write the formula, you're going to write an H first, write the symbol for the nonmetal, and you crisscross charges on this. Now hydrogen is group 1, so it's always +1. So really, you're just going to take the charge for the nonmetal and put it on the hydrogen. So let's do an example of that. Let's say I have hydrosulfuric acid. Okay, I know it's binary because it starts with hydro. The ones we'll learn about tomorrow do not start with hydro. So that's how I know it's going to be binary, is that it starts with the word or the prefix hydro. So my element here is sulfur. So I'm going to write my H first. I'm going to write my S. Then I'm going to grab my periodic table and figure out the charge of sulfur. Sulfur is a group 16 nonmetal, so it has a charge of 2-. So I'm going to take that 2- charge from sulfur and I'm going to put it on the hydrogen. Hydrogen is 1+, and we don't write ones, so this would just be H2S. Let's say I had hydrofluoric acid. Very common acid, extremely weak acid, but very potent acid. We use that to etch glass. It's quite an intense acid. So we would start with the H, and then our element here, our nonmetal, is fluorine. So we put the F for fluorine. Now we'd go to our periodic table and look up the charge of fluorine. Fluorine is a group 17 nonmetal, so they have a -1 charge. Now since hydrogen is +1, fluorine's -1, when we crisscross it, we don't write 1, so this would just be HF. All right? So you just have the rest of class to practice this.